All right. So where was I? Was basically having a differential. I don't know what I'm doing. What was I saying again? Okay, so I cleaned this up. What I want to basically say. Let me get my computer phone. Of course, I forgot I had this on. So yeah. So hello, everyone. Uh, yeah. Basically, Zoom again because Zoom is superior everywhere. Okay. That feels weird. So I was just basically changing it to more like standard form where it's more visually appealing. Um, I will say one thing. Currently, I'm not working on new problems too much, except for a few over here and over here. Basically, fixer uppers. Basically, this is a new question, but I'm just fixing up the old question is more likely what I'm doing. For example, a big fixer upper was this question that I'm shocked I didn't notice right away. Wait a second, this question is very flicking dumb. The way I I've made it. So this is the question here. So basically, these are hooks over here. And imagine a very, very fine hook, where you basically can get any value you want from anywhere. Basically, these hooks are like hook, 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 hook. You can hook it somewhere and it's continuously forever. Which means I should probably make an error order, but yeah, but 5.6999 meters is the correct answer for 15 a 15-meter length with the angle being um 30. Now, if I were to change the angles, then the final equation would be different and everything would be different. Uh, Clearly I didn't do that. And I just feel as I uh made a mistake again. Uh because of my hubris of thinking I fixed everything. No. I didn't expect it to be a mistake here. Definitely not here. So this x is supposed to be L minus x, and I just deleted everything, so I had to retype everything. No, I did everything. Oh my God. I'm just laughing at this point. I thought I did everything. For that, yeah. But it's not a very big change. It's just a change of numbers. It's not hard change. It's not. Let me show you how fast it is to change. I mean, yeah. Sometimes you have to go to overleaf, but for something simple as this, uh, I don't go to overleaf. I just do it by hand here. If I am doing something more, or way more, let's say more intensive, I will go to overleaf to fix everything up to make it look pretty and everything. Overleaf is so much like LaTeX is such a superior format than Google Docs is evil, 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 evil. Um, I call it evil because some of the formatting is such a pain. Like some of the format is like just looks ugly. But I like it because it's like faster for me than typing out code. Uh so it's like a trade-off basically. Like, well, you could say that yeah, it is bad, but at least you don't have to type it like 50 lines of code to solve one problem. Like there's a reason I choose this versus LaTeX. LaTeX is good for cases where you don't have to deal with a lot of the scrutiny of oh I did it wrong. Without the scrutiny of some of the you have more options basically to make it cleaner. but and I'll be honest, I think the best middle ground is actually Microsoft Doc. But the problem is I started this out in Google Docs because it was free at the time, and I was like was not willing to shell out $25 as a broke college high school student. So basically, I started with Google Docs. So I'm continuing with Google Docs, and Google Docs, I have to say, you infuriate me sometimes. Um, no, you're awesome. You're cool in most cases, but these equation features, let me show you what I mean. Um, when I do something like this, I cringe and say, "No, I'm gonna go to that space thing. I'm gonna go to latex and fix that shenanigans because it just looks bad." Anyway, I fixed that up real quick, so we can fix that up. Let me show you a little bit more around on what I fixed and did. So I deleted as you can see, I deleted all the code to make it more clean. Although some of the flux needs to be a little bit more. I don't know. Another thing I did was add. Oh, this is the only part I didn't actually type out again because I like that format over here. Anyway, I also did a matrix section really quickly. So matrix section was lacking, and you can see latex here. This is basically all latex if you didn't know. So latex is supreme. So when I do anything in matrix, unless if it's a 3 by 3 matrix, if it's a 2 by 2, well, I go away and I do a I can do a 2 by 2 with this format, but if it's beyond a 2 by 2, I have to go to latex and screenshot it there, because it's just better there. Anyways, as you can see, I decided to do all of it in matrix. So you can see clearly by X being a fancy matrix form, you can only do it in latex on that one. So we get this finally, and I give two options for you guys uh to get. So technically you can have I say 3 by 1, which is 3 rows by 1 column, but in reality, it's the final information. So if you want to store it as a row array, row vector instead, it's technically not wrong. It's just that to be dimensionally consistent with the how normal people do it when they do A -1 with B, I make it that way. But if you do it the another way, you can technically do a store matrix operation a different way and get the right answer. Um, I would not do it like that, but you technically could, theoretically. Yes, you could technically do it. It's not recommended. Now I'm thinking in my brain how you would do that. You have to invert everything. You have to change the components over here and the meaning of the components. Then you have to. Oh, that's hard. Ah, no, no, I'm not doing that. But yeah, just follow just improving everywhere I go. Now, another improvement here is that we have made it so that the order makes sort of sense. So we go from the definition and ideas of limits. We start with limits, and we continue with discussing basic limits. We go limits, and then we go and just show a little bit of a derivative and a chain rule and a method of limits and derivative a little bit more derivative, and then we do intro to integrals and Riemann sum. But we start with a derivative first, because we just recap from the previous, like everything here. We have finished all this, so we're just slamming it here as a recap tool, and then we're just continuously going down and talking about how the antiderivative or integral is the same thing. And we start with this idea of the sum, uh, because sum is always interesting. Sum is always the funnest thing. I mean not the fun, but always something I always do later on. It becomes a pain a little bit, but summation is something I always like, do. Well, how do you describe it? I don't know. Summation is something that we do basically. I mean, technically Riemann sum is not the best. You would use Simpson 3/8 or something with you know matrix with other stuff, but it's fine, good enough for now. It's very intensive if you use that method, but we'll see. Actually, we might want to change this, but I kind of like how I set this up. So I'm just keeping it for now, but I might want to change that real quick. So more Riemann, more integral. We're just continuously dicing out integrals basically. And then we finally go to simple differential equation because it kind of relates to a derivative and an integral at the same time. You can kind of see the relationship between a derivative over here and an integral over here. So we're just getting a little dense in the slope and how, because we can get a differential equation, we can get a slope. That kind of makes sense over here. We're getting a dinch over here. We're getting a little bit of a bone marrow connection, a little bit. And then we go to min and max. Very non-confrontational. And then because I don't really do any of the hard min and max question, mostly due to you would do that again in 2D, and I have a very hard question over there in 2D. So I just said, yeah, we'll just make it simple. And then we go to some really interesting derivative, very fast derivative. I don't really go too much because there's no real point to this kind of derivative stuff. Um, and then we finally go to funky U sub and U sub integrals and the BCMC. You can kind of see the interesting. We're going another step above, after integral again. Uh, a little bit of clean up here and necessary. All the red lines are gone anyways. Then we go to tricks basically. So you can kind of see that it's kind of formatted in a way that it's like, yeah, they're done. And then we get a system of difficulty while we add things from the previous usually. So yeah, so I think, and then I don't think there's any more jumps anymore. There used to be some kind of jumps over here and there, but nowadays I think we have recovered enough that there's no jumps, and then we do, yeah. So basically, I've been cleaning up this whole place, and I think the calculus is done and the multi-calculus is basically done, uh, which means that the physics is like halfway done. We have finished this one, finished that one, finished that one, finished that one, finished that one. By finish, I don't mean we're not going to add more. There's a reason I trying to keep it below 600. I want that 50 pages to make me think of new questions, and I'm going to put it here and make it more interesting. Math and density we have done to the extent. Uniform, we definitely have finished this one very intensively. And then energy, we have the spring is going to be in another section because spring is a little harder. We have a discussion on collisions a little bit, and then we're going to go to basic Hooke's law a little bit because we go back to it in differential equations anyways, the harder version. And now we're doing moment time, which is inertia. Um, yeah. So yeah, I think we're not done redoing all the inertias, although we definitely need to do all of this again because this looks so messy I can barely read it. Um, yeah, definitely redoing all those. But you can see that we're almost done with the physics, which means that we're almost done. We're in a state where book one is operational to use. It'd be horrible to use, but it's operational now. Someone could crack this book open and say, "Yes, I understand what the hell is going on from A to Z." Even there's big jumps, like there's gaps of knowledge here and there, but you can definitely go from 1 plus 1 to here with enough time. Enough time. Will that time be longer than normal? Probably without other books to help pad some of the worst offending bumps. Um, but we're getting closer to that goal of having it clean. So the thing is, I'm thinking of moving the linear algebra to the book two instead. Um, Interesting enough, I think I would rather have partial and the numerical, but I'm not sure. I haven't decided yet. I'm thinking in my head, should I? Because we have the basic linear algebra stuff that I need, basically. The other stuff is basically just if you're a computer scientist, it's more important. But for now, it's like the only thing I need from it is rank for Buckman pi theorem and panel method, matrix operation with the vortexes and everything. I guess that's useful. Yeah, yeah, matrices are very useful. And I can also think structural engineering with the pan oh my God, they're so useful. Oh my God, need matrices here. Sorry. Matrices are so useful. I take it back. Matrices are so important that I need to have it here. Man, my brain is not thinking correctly. Of course it needs to be here. Yeah, I just don't. But there's a lot of useless factors in here too. But eigenvalues are so useful. You need it. You need it. You need to know eigenvalues, honestly. Okay, fair enough. Fair enough. We'll keep linear algebra here, and then I'll fix it up. And then the other stuff I need to fix up because it doesn't fit the page properly. So, for example, this. And fun fact, this is Newton's method is the reason why it would have been very easy for me to do the square root of the function on top of the derivative on the bottom. It's because of Newton's method. You can very easily do it. Um, yeah. ODE 45 would have been easier, although yeah, yeah, it would have been easier. All right, I'm gonna stop here.